The vine snaps tight around the climber's waist. Below him, the cliff vanishes into shadow. Above, a rock opening hums. Then the bees pour out. They strike his face and crawl beneath his rough covering. Smoke rises below, but the wind pushes it away. One hand grips the vine, the other reaches for a heavy sheet of honeycomb. If he falls, his group loses a healthy adult. So why would ancient humans risk a life for something sweet? Part of the answer is simple. Honey placed a large amount of energy in one hidden spot. But calories alone do not explain why people returned to the same danger again and again. The complete answer begins with what they learned from the first successful climb. The climber is a plausible composite, not a documented individual. No one recorded the first honey hunter, the first hive people found, or the exact method they used. What survives is indirect but powerful. Prehistoric rock art in several regions includes scenes interpreted as people collecting bee products. Famous examples from eastern Spain show human figures approaching wild nests with climbing aids. Their exact ages and some details remain debated, so they cannot identify the first hunt. They do show that dangerous, organized honey collecting was real. Chemistry supplies a different clue. Beeswax can leave a recognizable pattern of fats inside ancient pottery long after the honey itself has disappeared. The evidence proves that people exploited bee products, but it leaves a harder question unanswered. What made the danger worth repeating? Imagine a small group moving through a dry landscape near the end of a difficult season. Fruit has become scarce. Hunting has been unreliable. Everyone is spending energy faster than the land is replacing it. A forager notices bees crossing an open patch of sky. They are not moving randomly. Several vanish in the same direction and later return. The forager follows. That behavior leads toward a crack high in a cliff. The buzzing is faint from the ground, but it never stops. There is food above them. Honey was not humanity's first experience of sweetness. Ripe fruit, berries, roots, and plant sap could all taste sweet. Honey was different because bees had already gathered and concentrated the reward in one place. Wild comb might also contain pollen and developing bees, which could add fat and protein. The first taste was probably not the breakthrough. The breakthrough was remembering where the hive was and deciding to return prepared. The group now faces a calculation with no safe answer. A healthy adult can gather plants, carry children, hunt, build shelter, and protect the camp. A fall could remove all of that in seconds. Stings could blind the climber temporarily, cause swelling, or trigger a severe reaction. Most stings would not automatically be fatal, but hundreds of angry insects beside a cliff could turn one mistake into a disaster. Walking away also has a cost. The hive may contain more accessible energy than the group has found in days. Hunger changes the meaning of risk. A climb that looks foolish after a successful season can look necessary during a bad one. But reaching the hive is only the first problem. The bees must be controlled. The climber must be supported. The comb must be removed without losing everything to the rocks below. One person cannot solve all three problems alone. Perhaps someone in the group has noticed that smoke changes the behavior of insects. Perhaps plant fibers have already been twisted into carrying cords. Those observations could be combined into a plan. No archaeologist can prove that this imagined group used smoke, vines, hide coverings, or a particular cutting tool. Rock art and later honey hunting traditions show that people could use climbing lines, ladders, smoke, containers, and teamwork. They do not prove that every prehistoric group used the same equipment. so the reconstruction must stay cautious. Several people twist and test a fiber line. One person prepares damp material that will smolder. Others choose a place where they can brace themselves below the cliff. The climber does not rise because prehistoric humans were fearless. He rises because the group has reduced a blind gamble into a plan. Then, the wind changes. Smoke that had been drifting toward the opening blows back into the climber's eyes. The buzzing becomes a roar. Bees strike the people holding the line. One person loosens a hand to cover their face, and the rope jerks sideways. The climber's foot slips. For a moment, his body swings away from the rock. The group below pulls backward. The line stretches. Fibers cut into their hands, but it holds. The climber finds the wall again and reaches the opening. Inside, the cavity is crowded with comb. Some cells hold honey. Others contain developing bees. The entire structure is heavier and more fragile than it looked from below. He begins separating one section. A crack runs through it. The largest piece tears loose before anyone is ready. People below move beneath it with a hide or bark container. Part of the comb hits stone and bursts. Part of it is caught. Now, the climber still has to get down. Scenes like this rarely survive in the ground. Honey is eaten, dissolved, fermented, or destroyed. Fiber ropes decay. Smoke leaves no simple label explaining why a fire was made. Beeswax survives more clearly. Researchers have identified the chemical fingerprint of beeswax in Neolithic pottery from Europe, the Near East, and North Africa. The evidence reaches back at least to the 7th millennium BCE, near the early spread of farming in parts of those regions. Another study examined pottery associated with the Nok culture in what is now Nigeria. It found beeswax signatures in vessels dating to about 3,500 years ago, evidence that bee products were being processed in prehistoric West Africa. But beeswax in a pot does not automatically mean someone poured fresh honey into it. Wax could have entered during honey processing. It might also have been used for sealing, waterproofing, fuel, medicine, or another purpose. Chemistry confirms contact with bee products. It cannot reconstruct the exact meal. That limit matters because the most important part of honey hunting may leave no residue at all. At the base of the cliff, the climber finally reaches the ground. His face is swollen. His hands shake. The line is frayed and much of the comb has been lost. But enough remains. The group can chew the comb and share the honey. We cannot know who ate first, how the food was divided, or whether this particular hunt happened exactly as imagined. What matters is what a successful return could teach. The people now know where the hive is. They know the wind can defeat the smoke. They know the line must be stronger. They know where the climber slipped and which part of the wall offered support. They may also learn that destroying the entire nest removes a future opportunity, while leaving part of it could allow another harvest. Different groups probably made different choices. One meal helps for a day. A remembered method can keep producing food. And that is where the real value of the risk begins to appear. But turning a lesson into a reliable source demanded something the honey itself could never provide: a way for the entire group to store and repeat what one climber learned. Ancient humans did not keep risking their lives for honey simply because it tasted good. They did it because a dangerous hive could become a repeatable source of food once observation, tools, memory, and cooperation were joined together. Honey hunting became a technology. Not a machine, not a single invention made by one genius. A technology made from organized knowledge. People could learn to watch the direction of bees, recognize productive seasons, judge a tree or cliff before climbing, prepare smoke, strengthen a line, cover exposed skin, and divide the work. The reward was no longer only the comb brought home that evening. It was a method that could improve with every attempt. One dangerous event became a lesson. Several lessons became a routine. A routine taught to younger members became culture. That transformation changed the calculation. The cliff remained dangerous, the bees still stung, and some hunts still failed. But the group no longer approached the hive knowing nothing. Knowledge could not remove the risk. It could make the risk worth taking. Strength alone cannot reveal a hidden hive. Someone has to notice the bees. Someone must remember the location. A climber needs support below. Smoke needs tending. A container must be positioned before the comb breaks. Other people may need to watch for predators, fire, weather, or rivals. That makes honey collecting a group problem.
Historically documented and modern honey hunting communities have used many different solutions, following bee flight, climbing trees, lowering people on ropes, approaching cliffs, using smoke, and returning to productive nests. These societies are not unchanged copies of prehistory, and their practices cannot prove what a specific ancient group did. They show what is possible when ecological knowledge is shared. Children can watch long before they are strong enough to climb. Skilled adults can compare one season with the next. A failed attempt can warn the entire group instead of teaching only the person who was stung. The most valuable thing brought back from the hive may have been information. Much later, some societies moved beyond raiding wild nests and began managing bees more directly. Ancient Egyptian images show a close relationship between people and bees by the Old Kingdom around the 3rd millennium BCE. But honey hunting did not transform into beekeeping everywhere at the same time, and archaeology cannot draw one straight line from the earliest wild harvest to every later hive. Different environments demanded different methods. In forests, people could search hollow trees. In rocky country, they could use ledges or climbing lines. Some communities may have returned to the same wild colonies. Others eventually built or managed places where bees could nest closer to human settlements. The larger pattern is clear even when the details are not. Humans kept turning animal behavior into useful knowledge. Bees revealed their location through repeated flights. Smoke could create a brief opening. Wax could be separated, shaped, or used in containers. Honey could be eaten, mixed, or stored only for a limited time. The insects did not become harmless. Humans became better prepared. Return to the cliff. The group leaves with less honey than it hoped to collect. The climber is exhausted. No single meal ends a season of hunger. But the hunt has changed what the group knows. They know where bees hide food. They know which part of the plan failed. They know the cliff can be climbed. And they know the reward is large enough to try again with a better method. Ancient humans did not survive because they were stronger than every animal around them. They survived because they could observe danger, test a solution, remember the result, and teach it to someone else. Honey was more than a sweet prize. It was proof that humans could study something dangerous, understand its patterns, and turn risk into knowledge. And honey was only one dangerous food. The next mystery is how ancient humans decided which unfamiliar plants and animals were safe enough to eat at all.